For example 2, we're going to use two things to help us graph it. We're going to use all of the x-intercepts, which we're going to find by factoring, and the end behavior, which we've learned already. Well, not only are we going to use our x-intercepts, we are also going to use all of our intercepts. So x-intercepts, there's always going to be only one y-intercept. So we're going to use our intercepts and the end behavior. So first of all, this is an x cubed graph. It's an odd function. So its end behavior is going to act like a line, meaning the graph is going to start in the bottom left-hand corner and end in the top right-hand corner. Now to get the rest of the graph, to sketch the rest of the graph, we want to find our x-intercepts and our y-intercepts. How do you find x-intercepts? Well, you set y equal to 0. So if I want to find the x-intercepts, I make y equal to 0, and then I just have to solve. Well, how do we solve when we make something equal to 0? The best way is to factor. And so this is where what we learned in section 1.1 and 1.2 with the factor theorem, the remainder theorem, and synthetic division is going to come into play. Sometimes you'll get an example like this one where you can use your old factoring techniques to figure it out. So we'll do one like this one. This one has your old factoring techniques. Can you see that you have a common factor? You can factor out an x. And after you've factored out that x, what you're left with is a quadratic. You could factor that further. And in this case, it's going to be plus 3 minus 2. So if you wanted to find your x-intercepts, one of them will be at x equals 0, one at x equals negative 3, and one at x equals 2. Our y-intercept, how do you find a y-intercept? You plug in 0 for x. And in this case, if you plug in 0 for x, you're going to get that your y-intercept is 0 as well. So we found our x-intercepts, we know our end behavior, and for this technique, now we have enough information to sketch the graph. So when we go to graph it, what we're going to do is we're going to put our x-intercepts on the graph. So we will have 1 at 0, 1 at 2, and 1 at negative 3. And then we're going to use our end behavior to sketch the graph. So I know that since it starts down here and it's got to go through these points and needs to end up here, that this is the general shape of my graph. So this answer would be given full marks. This answer would be given full marks. What's the difference between, well, oops, there. Now it would be given full marks. What's the difference between the green graph and the purple graph? Just how big the local maximums are and how small the local minimum is. They're in different places. And so on your exam, when they ask you for a sketch, they're not concerned if the right point was supposed to be here and yours was up here, or the right point was supposed to be there and yours was way down there. What you need to do for your sketch is you need to have the correct shape, which has end behavior starting down there and ending up there, and a smooth curve. You need to go through all of your x-intercepts. Perfect. Just make them big so they go through. And that's all you need to get full marks for a sketch of a polynomial. the right x-intercepts, the right y-intercepts, and the right end behavior. In calculus next year, if you take calculus next year, you're going to find techniques for finding these local maximums or local minimums. If you wanted to add more accuracy to your graph, you could use table of values to figure that out. So for example, if I want to figure out where it goes through when x is equal to 1, I can go to my original equation and I say, what happens when I plug in 1? I'd get 1 plus 1 minus 6 is negative 4. So if I mark on my axis here 1, 2, 3, 4, it should have been right there. That's where that point should go through. That being said, we still don't know for sure if that's the minimum. Just because it's equally between 0 and 2, a cubic graph doesn't necessarily have to follow that the minimum's right perfectly in between them. It may be, but it doesn't have to be. So for a sketch, all we need to do is find our x-intercepts and our end behavior and draw a smooth curve through it. Now we are going to do this one, the main one as well. It's in your answer key. So you just have to watch, but I want to look at this one because the one off to the side, we could use old techniques for factoring to figure it out. For this one, where did it go? There it is. For this one, we have to use our new techniques for factoring. So I want to find x-intercepts, y-intercepts, and end behavior. So first of all, for the end behavior, I see that it's a 2x to the 4. My leading coefficient is positive, so I know that the end behavior is going to act like a parabola. So it's going to start in the top left-hand corner, and my graph is going to end in the top right-hand corner. If I want to find between x-intercepts and y-intercepts, the y-intercept is going to be the easier one to figure out because you plug in 0 for x. Can you see that if you plug in 0 for x, 0, 0, 0, 0, minus 6, you'll get minus 6 for your y-intercept. For your x-intercepts, you want to plug in 0 for y, we're going to need to factor. So in factoring this one, okay, there's my function. I'm going to use my factor theorem and my remainder theorem. Let's say I plug in 1 because mental math, that's the easiest. And hope that you get 0. So if I plug in 1, I'd have 2 minus 1 minus 14 plus 19 minus 6. And that is equal to, yes, 0. That means that x minus 1 is a factor. So we can go to our synthetic division. If we're dividing by x minus 1, there would be a positive 1 out in front. 2, negative 1, negative 14, 19, and negative 6. We have to be careful that those were in the right order. And if we check in the question, they were. We also have to be careful that none of the powers were missing. So we'd have to include a 0. But in this case, none of them were. So synthetic division, bring down the 2. Multiply 1 times 2 and add. Multiply and add. Multiply and add. Multiply and add. And if everything works out, because you said it's a factor, you should get a remainder of 0. So that means that f of x, our original function, is equal to x minus 1 was the factor. Here we're writing our division statement, and we get 2x cubed plus x squared minus 13x plus 6. And because it's an x cubed, we need to do this process again. So I'm going to let p of x equal this one to see if I can figure out something that will divide that. I'm going to cheat a little bit and look at the answer so we can go faster. Okay, so notation-wise, if that's p of x, I'm now going to try p of 2, which will be 2 times 8, 16, plus 8, minus 26. Did I do everything right there? Oh, 2 squared is not 8. This will be 4. There we go. And if you add it all up, sure enough, that's equal to 0. That tells us that x minus 2 is a factor. And if we do synthetic division with x minus 2, you'd put a positive 2 out front here. We're dividing this part, 2, 1, negative 13, 6. Bring down the 2, multiply, add, multiply, add, multiply, add, and sure enough, we get a remainder of 0. So now, once again, I can write my division statement. And I'm going to write it for f of x, not for p of x, because that was my original function. I had already figured out that x minus 1 was a factor, so that will stay there. And now I figured out that x minus 2 is a factor, and I'm left with 2x squared plus 5x minus 3. And once you finally get to something with a quadratic, we can factor this completely. And if I want to find the x-intercepts, then I'll make y equal to 0. So factoring this last part has to be 2x and x. To get 5, I'd put a 3, so my outside is 6, my inside is 1. Plus 3 minus 1 makes a plus 5. And so from this, when I put in 0 for y, I find out my x-intercepts are those 4. So after factoring completely, we can now go to our graph. And at 1 and 2 and a half and at negative 3 are our 4 x-intercepts. We also know that our y-intercept was at negative 6. When drawing a graph, if you just draw the dashes on an axis without labeling with a number, it's unclear whether or not you're going by 1s or going by 2s or going by 10s. And so they will have, there's an error on the exam that you haven't labeled your graph if you don't label your axes with numbers. So it's not enough just to go dash, dash, dash over 3 and mark a point and say that that point is 3. You need to have some place on there that indicates what each of your dashes stand for. So as soon as I put negative 6 here, that's fine. We have our points. We know that our end behavior was like a parabola. So now we have enough information to draw our graph. And so we're going to start up here. We're going to go through this point. We swoop down, we go through this point, 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 we end pointing up like that as well. Again, we don't know how deep it droops down, where the minimum is going to be, but as long as your curve is smooth all the way through, you're going to be fine. Okay, so using factoring, try questions 7 and 13 right now.